heat transfer. In this worksheet, you're going to be using the formula for specific heat, and you'll find that in the notes in your reading material. So here it is. Here's specific heat. And what specific heat is, it is the amount of heat energy that's needed to raise the temperature of 1 kilogram, or sometimes 1 gram, depending on the unit that we're using, of a substance by 1 degree, either Celsius or Kelvin, because the change in 1 degree Celsius or Kelvin is the same amount of temperature increase. So specific heat is just how much heat energy it takes to raise 1 kilogram of a substance by 1 degree. But usually we don't have just 1 kilogram of a substance, or we're not just changing the temperature by 1 degree. So, pardon me, if we have 2 kilograms of a substance, then we know we would need twice the amount of heat energy to warm that up. Or if we wanted to warm it by more than 1 degree, we would need to multiply by the number of degrees that we want to change it by, because that heat energy is only enough, when we're talking about specific heat, to change 1 kilogram by 1 degree. So here is our formula. Q stands for heat energy, M is mass, this triangle we read as delta, delta T is change in temperature, and then this Cp is the specific heat of the substance. So each substance, each pure substance, has a specific heat, an amount of heat energy it would take to raise the temperature by 1 degree of 1 kilogram of that substance. Now, if we want to know the amount of heat energy to raise more than 1 kilogram or more than 1 degree, we'll multiply by how much we actually have and the number of degrees we actually want to raise our temperature by. So in these problems, this first one asks us how much heat energy is needed. I'm going to go ahead and write our formula, our specific heat formula, right here on the page so we can see it. So Q equals mass times change in temperature times specific heat. And you can see here that our data table gives us the specific heat of 6 different metals. And you can see that every metal takes a different amount of heat energy to raise 1 kilogram by 1 degree. So here we are. How much heat energy is needed to raise the temperature of 5 kilograms of water from 21 degrees Celsius to 100 degrees Celsius, and it gives us the specific heat of water in this problem. So I know that I'm finding heat energy, which is Q. So I don't know Q, and it equals the mass, which it gives me is 5 kilograms, times the change in temperature. And to find the change in temperature, we just need to know how much the temperature is going to change. Well, it's going from 21 to 100, so if I take that and I subtract them, 100 minus 21, it gives me a difference of 79. So that's how much the temperature is going to change. And then times the specific heat of the substance, and for water, it's 4,186 joules per kilogram Kelvin. So I'm going to plug this in. 5 times 79 times 4,186. Sorry, I didn't see the 6 there. And I get quite a large number, because as we already know, it takes a lot of heat energy to change the temperature of water. So my Q will equal 1653470. That is 1,653,470, and that is going to be in joules, because energy is measured in joules. So for this one, I needed to find Q, my heat energy. In number 2, though, we need to solve for specific heat and then use that to identify the metal. So in this case, we know the amount of energy, so that's going to go where Q is. 14,014 joules of energy is our Q. So 14,014 joules of energy will equal, we have the mass here as 2.8. The change in temperature is from 22 to 35. That's a difference of 13. And we don't know the specific heat. So what we'll need to do is take these two and multiply them together, and then bring them to the other side and divide. So 14,014 divided by whatever this gives us will give me the specific heat of the metal. Once you've solved for specific heat, whatever it is, you can look up at your data table, find the amount that it's closest to, and that will tell you which metal you have found the specific heat of. So for example, if your specific heat comes out to be right around 140, then you would write that it's mercury. So for each one of these, make sure that you're solving for whichever thing it's asking you for. So in this one, it asked us for how much heat energy, so we're solving for Q, and we just plug these three in. This one, we were asked for the specific heat, so we plug in the heat energy, mass, and change in temperature and solve for specific heat. And each one is going to be done a little bit differently. So do be careful that you're plugging in the numbers where they belong and solving for the one that you do not know. This does go on to the next page. You'll continue to use the same formula to do all the way through number 17 here. And if you do get stuck on any individual problem, please do come ask your questions.